So the original idea was to talk about an experience I had with using XGBoost for a customer behavior prediction project. As I was working on the background, for the XGBoost tool, I started putting slides together about classification trees, and I don't know, I was asking Sarah, maybe too basic for you guys, maybe, I don't know, what should I?
Oh, I'm ready to find out.
I just presented on like AI and ML, and
Okay.
everyone here probably knows those words or might have heard them before. So.
Well, okay, if it's too basic for you guys, just let me know and I'll, speed up, fast forward it, finish soon. Okay, well, let's start. My name is Guillermo. Let's go with the hard part of the presentation. The name. The U is silent and double L is Y, so the name's pronounced Guillermo. And I've been working for HP for 33 years or so quite some time. I came from Mexico 20 years ago, and I had the opportunity to work on predicting cancellations for an HP program, trying to predict customer behavior using XGBoost. That's the idea. It was, unfortunately, I cannot reveal everything about what I did.
You have NDAs in place? What?
Yeah. So the initial intent was to tell you guys about my experience with that project, with this machine learning project that I worked on. But I started putting these slides together and as a background, and you guys tell me if it's too basic for you guys, then we can just leave it for some other day. So basically, we use a tree model, and tree models, as I think you guys know, are those if-then-else rules. And one of the reasons we use XGBoost as opposed to deep learning or other models is that we wanted at the end to have an idea why a customer would be classified as a potential canceller or churner, as it is known. And black box models like neural nets would not give us so much the decision or the information that decision trees would give us. So that's why we went for that model. And this is sort of like an example. It's not exactly the project I worked on, but to give you an idea, it was some service HP provided. You would have to become a member, and it would pay monthly for that service. And I'm just adapting that to what I did to this example, simple example here. And the idea of the project that I worked on was to have the history of users and which how many of them and which ones would cancel and which ones stay in the program. And based on that, we would train a decision tree to classify potential customers. And based on that classification, marketing would intervene and would send emails to the customers to try to avoid a potential cancellation. So far, so good. Okay. So the idea was to use the tree, and as as a normal tree, you try to find the split points that give you the best partition to classify. And this is just an example. Here, this is not what I do. And just the idea. What we did. This is what I was trying to show here for people who did not have the opportunity, haven't had the opportunity to work with classification trees or decision trees, to have an idea how they work. If there are no questions, no, great. Continue some concepts. Oops, sorry. Of course, you can classify. like this using two features, two dimensions. This is kind of a graphs that for didactic purposes are really good, but in reality, I think all of us have, people have worked on this, have an experience that in reality the patterns are complex and multi-dimensional. You require, not just two features, but a lot of them. For example, in the case that of the project, we started out with a database of 400 columns, and we had to start shrinking down. The important features that would really determine, the correlate with the cancellations. And anyway, just in case, people had quick questions about, how a tree classifies. So some concepts, measures,
So Guillermo,
yes.
so you began with all these columns, and then you determined which ones were correlated with the cancellation.
Correct.
Yeah. And then when you actually did something about it, like these marketing interventions, or send the sales guy to be more polite and take him out for dinner or something, did you also feed that information back in to see what a difference it made?
Yes, that was at the end of the program, yes.
Oh, okay.
But
So would that be called like A/B testing? Like
that was just sort of like A/B. Yes, correct. That was part of the project that was studied. And of course, this is making it simple. Maybe if you guys want, next time I can go in more detail. For example, it was not just finding the features that were most influential, but also we try to do some data transformations, take some of the features and create new features that would help with the classification. And so that was what the project, also that was part of the project too. Okay, so an example of impurity, hard, I'm pretty sure people know about this. For regression.
we do want to know all of this too. You don't need to skip over it.
Okay. Well, basically, the idea is that the best way, one of the best ways to find patterns is to partition, in a greedy form. Try to find, the partitions that give you the maximum, purity. So in other words, that display, the data in the two classes or the K classes, that you are trying, to differentiate, and predict. So the idea of here, we just want to show you what is, the metric or the measure, to tell, how a partition, is good, or an algorithm, needs to keep searching for the right partition and say, this is the spot, where, the value, the feature and the value, where I can divide, the data into, and classify, the observations. Hard to beat. This is a very, famous and popular, algorithm. That it's greedy and try to recursively split, the data in regions as shown here. And the algorithm has been very successful. We just got to be careful, with overdoing it, in partition in very small regions that would give us overfitting. So that would be a problem. There are other problems like leaky models, but that's a different problem. But this is one algorithm that's it's become very popular. So there are other ones that I haven't used. I just wanted to mention those. And of course, people that have worked with trees. Know that they have to limit the growth of the tree because at some point, I mean, it loses, I mean, the effectiveness, or it's not general, I mean, enough. I mean, it becomes too specific for the training, I mean, data set. So, I mean, when you train, I mean, the tree, I mean, you have to limit some of the parameters and, of course, tinker with that and tune, I mean, the tree. So it is general enough to predict, I mean, even if it's not with the best accuracy, but I mean, general enough to predict, I mean, for the whole, I mean, population, I mean, of samples that you want to, I mean, apply in the model on. And there's the ensemble, I mean, learning that's becoming a very, I mean, effective technique, which is based on the idea that weak, I mean, models, weak classifiers, even if they just barely get the job done and they're right just 50% of the time, I mean, can be combined to give a very good prediction as you start adding, I mean, what's called the additive, I mean, you know, model for I mean, classifiers. And there's also the bagging, which is use, I mean, the data, the same data in sample, I mean, with replacement, I mean, for to use to train, I mean, different models, I mean, using the same data. And that technique, I mean, it's also used for by XGBoost. So that's what I mean, I'm mentioning that. Random forest, I just heard, I mean, that mentioned, so I'm pretty sure people know about them. There's the AdaBoost, which is a good, I mean, I would say, let's say a breakthrough in a way, I mean, because instead of training, I mean, on the data itself, I mean, it trained on the errors or the so-called residuals. Well, in this case, it calls, I mean, the errors, but I mean, we'll see the other one, I mean, that's the gradient, I mean. So they train not on the data, but on the errors. So as an error increases, I mean, the algorithm is forced to consider the error and split the tree based on the value of an error. So it makes the algorithm, I mean, effective in a way in catching errors and having a better, I mean, split than just using the data. So that's just the algorithm, I mean, and there's gradient, I mean, boosting, which is the one used by XGBoost. For this algorithm, I mean, I just to get a simple, I mean, example, just try to, I mean, follow, I mean, the algorithm, I mean, as well, it depends on where you find out. When you go to YouTube, I mean, you find a version of the algorithm different from the version in textbooks. So it depends on what textbook, I mean, you use. I mean, I use the statistical learning, I mean, Trevor, I mean, or,
Yeah.
yeah. I better shut up. This book. So, and basically the idea of the algorithm is just that you compute, I mean, probabilities. Well, you compute, I mean, the initial probabilities based on your data, and with that, I mean, you start getting, I mean, the errors, the so-called residuals. And this is the part that, unfortunately, here is not very clear, I mean, but in reality, that's where the gradient part, I mean, comes into play. And then you train, I mean, based on the residuals, the errors, and then based on that, you compute, I mean, for each one of the regions, it's called, I mean, gamuts, I mean, that will give you the log of the odds here, based on the number of, you know, on the errors and some of the errors with respect to this sum, I mean, of the error, I mean, with the respect to itself. I mean, this gives you the log of the odds. I mean, that you add and apply. I mean, and this is not a probability that you have to then use this softmax, I mean, a function to turn it to probability. And that's, well, I had an example and it was worth, I mean, for example, and that was basically it. I mean, and after that I was planning, I mean, to go over an XGBoost, so short. But I don't know, we can talk about, I mean, the XGBoost and the experience, I mean, I had with it, I mean, for a time, if you guys want.
It's entirely up to you.
This is where I stopped. So
So then maybe we might tap you again. Next time we meet in 3 months.
I'll be more than happy.
Okay.
So you can do all that next XGBoost, everything, all those?
All those, but, and more on this. So yeah. So thank you.
Thank you.